Have you ever wondered when the VR headsets can get more comfortable? I mean, yes, they're getting thinner and lighter, but after several hours of wearing them, it's still easy to feel eye strain, and the LCD displays of the headsets are just too glaring. Anyway, nowadays VR games are getting more and more popular. But wouldn't it be better to play VR games without a dumb headset? Turns out our brains have their own VR gaming systems, and we can play them every night. Scientists have found out that what we do in our dreams is exactly like playing virtual reality games, and it has connections with consciousness. Research shows that during the REM sleep, which is short for rapid eye movement, dreams mainly show the features of primary consciousness, which includes perception and emotion. Scientists consider REM sleep a brain state, which can be analyzed with techniques such as EEG and MRI, while dream is the information of what the brain does during REM sleep, often reported by the dreamer. Human beings have a large amount of REM sleep before birth and in the first year after birth. It decreases afterwards as waking time and cognitive abilities increase, but still remains about 1.5 hours per day in adult life. This suggests that REM sleep contributes a lot to the early brain-mind maintenance and helps maintain the brain functions throughout life. Indeed, scientists have carried out experiments on rats and found out that sleep-deprived rats lost weight and control of body temperature and eventually died. Research also shows that the main function of dreams may not be just recollecting the dreamer's past. It is possible that the brain is preparing itself for its functions in future waking states, which is just like pilots practicing flights in a simulator before flying a real plane. We definitely love these results because it can justify our long hours of sleep. But what if we end up dreaming when we should be awake, like in the classroom? How on earth does the brain switch between waking and dreaming states? Scientists have proposed a model of consciousness called AIM, which is short for three states: activation, input-output gating, and modulation. Activation represents the level of energy of the brain's neural networks. It's like the on-off switch of a power supply. The neurons of the brainstem control the activation and deactivation of the brain. Input-output gating describes the process in which the brain inhibits or enables the sensory input and motor output, just like we plug the computer's camera and printer in and out. This gating mechanism is also controlled by the brainstem. When we are dreaming, we consider ourselves awake. External signals are not available in sleep, so the environment we experience in dreams are simulated by our brains, which is just like the simulated world in a VR game. The brain simulates an internal environment in the visual system with PGO waves generated by several parts of the brain, and no matter how bizarre it is, we experience it as if we are awake. Modulations relates to the fact that the brainstem controls the chemical environment in the brain. The neurons in the brainstem release dopamine, noradrenaline, serotonin, histamine, and acetylcholine, which participate in the switching between waking and sleeping states. The AIM model creates a space that represents the transitions of brain states and shows that the brain states of waking and dreaming are cooperating to maintain brain functions and consciousness. So that's what our brains are doing in dreams. Instead of wearing a heavy VR headset and looking into LCD displays, we are playing our own virtual reality games just lying in a bed with closed eyes. Pretty easy, isn't it? Of course, we can't move in most of our dreams because of motor inhibition. So, if you want to do sports, set up a room and play with the VR headset and controllers. If you want to get your brain work better while at rest, just go to sleep.